Welcome to this lesson on the Precambrian Earth, the early Earth. For this lesson, you will need a copy of your guided notes. The success criteria for this lesson is you'll be able to describe the evidence used to determine the age of the Earth, understand why scientists theorized that the early Earth was hot. Today's vocabulary is going to be zircon, asteroid, meteorite, and we could throw in isotope as well because that is a huge question. The early Earth. For about the first 4 billion years of the Earth's 4.6 billion years existence, most of the life forms that inhabited the Earth were unicellular organisms. What evidence do these organisms leave in their existence? How did the Earth change during the Precambrian? How did these changes set the stage for animal life that exists today? Answers to these questions not only help us understand the history of the Earth, but also serve as a model for search for life on other planets. It may be possible to identify clues to the possible existence of life on other planets if rocks from those planets were the only evidence we have. After all the rocks, all that we have left are the Precambrian Earth. There's evidence of life's humble beginnings on Earth in Precambrian rocks. Most of the Earth's history is contained within the 4 billion years that make up the Precambrian, as illustrated in this picture above me. How old is the Earth? Evidence for the age of the Earth comes from zircon crystals found in Australian metamorphosed sedimentary rocks. These crystals are between 4.1 and 4.2 billion years old. Zircon is a very stable mineral that commonly occurs in small amounts of granite. Earth's heat sources. The Earth is most likely extremely hot shortly after it was formed, and there are 3 likely sources of this heat. The first source of the Earth's heat is from radioactive isotopes, were more abundant during the past because over time radioactive decay has reduced the original amount of the Earth's radioactive isotopes. A product of radioactive decay is thermal energy. The second source of the Earth's heat was the impact of asteroids and meteorites. Asteroids are metallic or silica-rich objects that are 1 kilometer to 950 kilometers in diameter. Meteorites are small asteroids or asteroid fragments that fell on early Earth, generating heat. The third source of heat was gravitational contraction. As a result of meteor bombardment and the subsequent accumulation of meteorite material on Earth, the size of the Earth increased. The weight of the material caused gravitational contraction of the underlying zones, which created thermal heat. Concept check. Question 1. What is the evidence that is used to determine the age of the Earth? Question 2. What are 3 contributors to Earth's heat? Now would be a good time to pause the video, answer the questions to the best of your ability, and then resume play. Question 1. What is the evidence that is used to determine the age of the Earth? Radiometrically age-dated zircon. What are the 3 contributors to Earth's heat? Radioactive isotopes, the impact of asteroids and meteorites, and gravitational contraction. This concludes today's guided notes for the instruction of the Precambrian time, the early Earth. Now progress on to your practice, to the early Earth practice.